Welcome to Unit 2, Lesson 15, Solving Systems by Elimination, Part 2. This will be a continuation off of yesterday's lesson. Our learning goal today is to think about why adding and subtracting equations works for solving systems of linear equations. We have one learning target for this lesson. By the end of this lesson, you should feel comfortable saying, I can explain why adding or subtracting two equations that share a solution results in a new equation that also shares the same solution. For our glossary terms, elimination, a method of solving a system of two equations in two variables where you add or subtract a multiple of one equation to another in order to get an equation with only one of the variables, thus eliminating the other variable. Our next glossary term, solution to a system of equations. A coordinate pair that makes both equations in the system true. On the graph shown of the equations in a system, the solution is the point where the graphs intersect. Our next glossary term is substitution. Substitution is replacing a variable with an expression it is equal to. Our next glossary term, system of equations. Two or more equations that represent the constraints in the same situation form a system of equations. Now we can start the Lesson 15 practice problems. Our first problem wants us to solve the system of linear equations without graphing. Because this lesson is specifically about solving systems by elimination, that is the method we will use. What I'd like you to notice is that in the system of equations, we have opposite variables. I have a plus 4y and a minus 4y. When I have opposite variables, I want to add these equations together. This gives me 5x plus 10x equals 15x. 4y plus negative 4y cancels out to 0. And 8 plus 46 equals 54. Now I have 15x equals 54. The opposite of multiplying by 15 is dividing by 15. So I'm going to do that to both sides to keep it equal. 15 divided by 15 is 1. So we just have x on the left. And then we have 54 divided by 15 on the right. We can simplify this by dividing the top and the bottom by 3. 54 divided by 3 is 18. And 15 divided by 3 is 5. Now that we know a value for x, we can substitute this value into one of the top equations and then solve for y. So I'm going to choose the top one. Since I see that the denominator for x is 5, I'm going to substitute it in where x is being multiplied by 5. So I have 5 times 18 over 5 plus 4y equals 8. Now the 5's will cancel each other out, and this gives me 18 plus 4y equals 8. The opposite of positive 18 is negative 18, so I'm going to subtract 18 from both sides to keep it equal. This leaves us with 4y equals negative 10. The opposite of multiplying by 4 is dividing by 4. So we're going to do that on both sides. 4 divided by 4 is 1. So this leaves us with y equals, and we have negative 10 over 4. This can be simplified because 2 goes into negative 10 and 4. Negative 10 divided by 2 is negative 5, and 4 divided by 2 is 2. So now that we know what x and y equal, our solution is the point pair x equals 18 fifths, y equals negative 5 halves. This point pair will make both of the equations in this system true, and if we were to graph these two equations, they would cross at this point pair. If you have any questions about this practice problem, please use class time to ask for further clarification. Our next practice problem says select all the equations that share a solution with this system of equations. So here are some tips for how I would go about solving this. The first thing I notice is that A and B both start with 7x. They got that by adding the 5x plus the 2x. So what we need to do is add these two together and see whether it would be a plus 3y or a minus 3y. So if we take 5x plus 4y equals 24, and we add that to 2x minus 7y equals 26, then that is going to give us 7x minus 3y equals 50. So that means B is correct and A is wrong. Next, on C, I see that they took the left side of the first equation and they set it equal to the left side of the second equation. The problem with this is that the first equation equals 24 and the second equation equals 26. So these two sides are not the same. This is like saying 24 equals 26, and that's not true. So C is not a correct solution. And the last tip I would give is that I notice D and E both have 3x to start with. They got that by subtracting 5x minus 2x. So that's what we're going to do. 5x plus 4y equals 24. And they are subtracting 2x minus 7y equals 26. Well, if I am subtracting, then the sign of everything I'm subtracting changes. This becomes 5x plus 4y equals 24 on the top, but it becomes negative 2x plus 7y minus 26. Now when I combine them, 5x minus 2x equals 3x. 4y plus 7y equals 11y. And 24 minus 26 equals negative 2. That means E is an equivalent equation and D is incorrect. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Page 2. Students performed in a play on a Friday and a Saturday. For both performances, adult tickets cost $A each, and student tickets cost S each. On Friday, they sold 125 adult tickets and 65 student tickets and collected $1,200. On Saturday, they sold 140 adult tickets and 50 student tickets and collect $1,230. This situation is represented by this system of equations. Number 1. What could the equation 265a plus 115s equals 2,430 mean in this situation? What I notice for number 1 is that they added the top equation and the bottom equation. So to get the new equation, the first two equations were added together. So when they want to know what this equation could mean, the new equation represents the total tickets sold and money raised for both days combined. Number 2 says the solution to the original system is the pair A equals 7 and S equals 5. Explain why it makes sense that this pair of values is also a solution to the equation 265a plus 115s equals 2,430. So for number 2, A equals 7 means adult tickets cost $7. S equals 5 means student tickets cost $5. The total tickets and money earned increased, but the ticket cost stayed the same. This is why it makes sense that the variable values did not change. They stayed the same. If you have any questions about this practice problem, please use class time to ask for further clarification. As we look at our last practice problem, it asks which statement explains why 13x minus 13y equals negative 26 shares a solution with this system of equations. And there will be one correct answer that we're looking for. So if we look at A, it says because 13x minus 13y equals negative 26 is the product of the two equations in the system of equations, it must share a solution with the system of equations. The word product means multiplication. We did not multiply these two together, so A would not be correct. Choice B says the three equations all have the same slope but different y-intercepts. Equations with the same slope but different y-intercepts always share a solution. What's wrong about this one is that equations with the same slope but different y-intercepts are parallel and never cross. So they would never share a solution. So B cannot be correct. Choice C, because 10x minus 3y is equal to 29, I can add 10x minus 3y to the left side of negative 3x plus 10y equals 55 and add 29 to the right side of the same equation. Adding equivalent expressions to each side of an equation does not change the solution to the equation. While that statement is true, 10x plus negative 3x would be 7x, not 13x. They did not add. So when it says that they added, that's the problem. And lastly, we have choice D. Choice D says because negative 3x plus 10y is equal to 55, I can subtract negative 3x plus 10y from the left side of 10x minus 3y equals 29 and subtract 55 from its right side. Subtracting equivalent expressions from each side of an equation does not change the solution to the equation. So if I subtract the bottom equation from the top equation, then negative 3x becomes positive 3x, and 10x plus 3x equals 13x. The plus 10y on the bottom, when subtracted, becomes minus 10y, and minus 3y minus 10y is minus 13y. And when I subtract the bottom equation, the positive 55 becomes negative 55, and 29 minus 55 becomes negative 26. Subtracting is what they actually did to get the new equation. So choice D is the correct option. If you have any questions about how to solve any of these practice problems from Lesson 15, please use class time to ask for further clarification before we move on to Lesson 16.